let's kick off and let's dive into this topic. So in tonight's discussion, we'll consider, first of all, why we might use site batch concrete for a residential project, some material issues that we may face, some batching accuracy of the plant, mixing, quality control, and finally some practices that we see on site that can lead to a poor quality concrete. And not forgetting the most important, our people. So let's first of all look why we might use site batch concrete. Site batch concrete is normally used in larger scale projects, and it's used for a number of reasons. Number one is potentially lower cost, but also it's used because residential projects carry tight timelines. So getting the concrete to site, having a consistent quality is very essential. Sometimes there are fines involved if the deadlines are missed. So making sure that the projects run on time is very, very important. And that's one reason why people use site concrete. There is also, as you see on the screen, some flexibility in production, different types of mixes that you may need that may not be available in the market. And timing, maybe you want to pour at night when it's cooler. Maybe the ready mix plant is closed. So having on-site production means that you can do that anytime you want. It's possible that you might be able to reduce your waste. You can literally batch what you need. You don't have to risk any wastage, and you can have control of the quality in some better control. But there are some negative sides to using site batch concrete. Site regulations. How do you treat the wastewater? Do you have to control the dust? These are important factors that are becoming more and more important. Deliveries of raw materials. What about if they're delayed? What are you going to do? That'd be a disaster. And then there's quality variation from the concrete itself. They're just a few of the challenges. So why do these problems occur? How can we eliminate them in order to ensure that when we produce for a residential building, we get good quality concrete? For the purposes of the next discussion, we'll assume that the mix design itself is working well. So there'll be no mix design discussion in this particular discussion. It's more about the problems surrounding that. So let's dive in. Now, we've discussed concrete before, haven't we? And we know that it's made up of natural materials. Our cement comes from limestone and clay. Where do they come from? Out the ground. Every batch of cement has slightly different chemical characteristics depending on the location of the source. Aggregates, fine aggregate, coarse aggregate, they're either dredged up or dug up and processed. And again, have different chemical properties depending on where they come from. That's important to note because if you're using more than one supplier, you should check that the material has the same properties. There are no major differences between the properties. Even the water that we use to produce concrete, is it from the mains? Is it potable? Is it from a well? Is it from a river? Where does it come from? The chemical properties of that water can affect the performance of our concrete. Finally, our choice of admixture. That has a big effect on the stability, the performance, the rheology, and the durability of our concrete. And we'll discuss that a bit more later. Then you have, on top of that, the plant itself. Even a top spec plant, a state-of-the-art plant, has some natural variation in the measuring equipment. The type of mixer, the mixing efficiency, they play a part in producing good quality concrete. So are we dry mixing in a truck? Do we have a pan mixer as we see there, or a twin shaft mixer? It's important to know our plant well and adapt our system to use that to optimize and to get the best quality concrete. So we have to recognize aggregate weighers, cement weighers, water weighers, admixture dispensers, all can experience fluctuation if they're not looked after properly. Of course, we also need to know that our team, the people running this equipment, they're familiar with the batching software. They know what to look for. They know what particular identifiers there are when problems occur. We'll discuss that a bit more later. With all these fluctuations and variations in materials and equipment, it's no wonder we see some fluctuation in the quality of our concrete. So there's the question. What can we do to minimize the variation and to ensure that we produce high quality concrete? Well, we'll consider 5 ways. They are the materials that we use, the batching accuracy, the mixing, quality control, and finally some of the on-site challenges that we face. So let's have a look at the first one, materials. When we are running a project like that, we have to use materials that meet the project specifications. Ideally, they should be free from contamination, because if there's contamination in our sand or our aggregates, that will have an impact on the quality of our concrete. For an example, if we use a poor quality sand just because it's cheaper, in the long run, the concrete may not be homogeneous. It may bleed or it may segregate, and it may cost us a lot more money in the final accounting. Again, we need to consider the location of the source. How far or how near is it to our plant? For 2 main reasons. There are other reasons, but these are the 2 main ones. We want to make sure that the materials coming to our plant are continuously supplied. We don't want to run out of sand or aggregate while we're in the middle of pouring a big raft. That's a big issue. So continuous supply is very important. Secondly, environmental concerns, green sourcing. Now this is becoming more and more and more popular. And as consultants and architects move around the world, these standards are being introduced. So many projects now want green certification. They want to use environmentally friendly materials, and that often includes how far the source is from the site. So these are 2 considerations we need to think about when we're selecting materials. Once we have selected the materials, then we need to think about how they're handled. So as you can see in the pictures on the screen, proper storage is important. Cement, it's a powder. We don't want any moisture getting into that. So it should be stored in a good quality silo to prevent clumping and degradation. The silo itself and the screw conveyors should be regularly checked and maintained. Aggregates, there's the pictures, should be kept clean and separated to maintain consistent quality. If the sand and the aggregate is mixing, it creates problems in the mix design when we're batching. Aggregates ideally, as in the bottom picture, should be shaded and ideally cooled if we're working in a hot climate such as Ghana. Some plants choose to cool their aggregates by spraying chilled water on them, and that helps to keep the final concrete temperature down. But of course you have to make allowance for the moisture content. We'll cover that later as well. Another consideration is our admixture. The compatibility of our admixture should be checked in the lab, first of all. What does that mean? The current generation of PC admixtures are more sensitive to cement chemistry than traditional lignosulfonate or naphthalene-based admixtures. And therefore, not all polymers work the same way on your cement. So doing trials to establish a well-compatible admixture will massively save you performance and money and time on your plant. And that's very important to do. We'll cover that later as well. Now, we should say, just as a note, that there is usually, and it's normal, to see a difference between the admixture performance in a lab and the admixture performance on the plant. That's because the plant mixer is much more efficient than the drum mixer you may use in a lab. and so we get better performance on the plant. Your local MC Biochemie representative can help you to select the right product and help you in that batching method. Talking of batching, what about batching accuracy? Now, as you see in the top screen, top picture, modern batching plants use computerized systems so that everything's weighed exactly, perfectly. But it's not quite perfectly, is it? We need to make sure, therefore, that moisture meters, weighers, dispensers are all working and calibrated. Calibrating the equipment every 6 months or so will ensure that we're dosing the right amounts, we're weighing the right amounts, and that our concrete is the right mix design. Our beautiful admixture dispenser there in the bottom right corner is fine, but we need to clean it regularly to make sure we're not over or underweighing. If we don't, then we can have serious performance issues for the concrete. Either we'll get rapid slump loss or maybe extended setting times. In some cases where the equipment's neglected, the dosing of retarders has meant that concrete doesn't set for 2 to 3 days. And on a residential project, that's not good. Another side effect may be that we have differential setting. Now, what is differential setting? Differential setting is where the concrete is setting at different speeds due to the batching process. And that can lead to different colors, crusting, and of course, cracking. All things we don't want. So regular maintenance of our plant is very, very important to make sure that our concrete is a high standard. Now, the most defining characteristic of concrete, of course, is the water-cement ratio. And that comes from many factors. Not only the added water that goes in from the batching, but also the moisture within the aggregates. So we need to check the moisture regularly, as well as knowing the absorption of the materials. Mixed design methods account for absorption and moisture. So we need to make sure that we're doing that. Otherwise, our workability may be more or less than we are targeting. Moisture meters need to be cleaned because they can get covered in dust. So we need to clean them regularly. And if we're manually doing the moisture, it's recommended to do it twice per day. Make sure to turn over the stockpile in your plant to avoid water settling in the lower part. And then we suddenly get a very wet load because we're not monitoring the moisture. So monitoring the water precisely, although it takes time and effort, will help us to make sure that our concrete is a high quality concrete. Now, let's think about mixing. Proper mixing techniques can be either dry or wet, but they're absolutely essential. Let me explain why. We just discussed the importance of maintaining the correct water-cement ratio, and that's vital, of course, for strength and workability. It is just as important to ensure that we mix the concrete properly. So we have to ensure sufficient mixing time to achieve a uniform, homogeneous, well-blended concrete mix. But more than that, the method of how we add the materials into the mixer has an effect. Generally, in the wet mix process, coarse and fine aggregates are put into the mixer. Maybe half the water is put into the mixer and given a mix. Then the cement and the ingredients, cementitious materials, are added and mixed. And then finally, the remaining water and the rest of the admixture is added. Now, in the most common mix designs and plants, the mix cycle takes approximately 45 seconds. But mixing time can depend on the plant. So it can range between 45 seconds and 2 minutes. If you have a brand new efficient twin shaft mixer, like in the bottom picture there, batching can be very fast. But if you have an older mixer with worn out blades, reduced efficiency, mixer that's not cleaned properly, then it can take longer. It is important, very important, not to rush. Don't rush batching concrete. It will impact the concrete quality and cause you issues on site. Timing also depends on the type of mix design that you're batching. So if you're batching a standard concrete, then short mixing times are okay. But if you're batching a mix with fibers, for example, then we need to make sure that those fibers are fully dispersed. We need to make sure the mixing is enough time to give proper mixed concrete. Now, we said the final stage of the addition was the addition of water and admixtures. The admixture addition point is actually quite critical in the mixing process. There are three ways that are commonly used in adding admixture. The first one, as you're seeing in the video there playing now, is everything is put into the drum at the same time, more or less, and mixed. This is simple, common, and used mainly for small drum mixers on site, such as you see there. There is a second one, solution addition, which is when on a batching plant, the admixture is pre-dissolved in the weighing water and then put into the mixer. Now, the third one, and the most effective one, is not commonly used. So it's after all the other added materials are in the mixer and mixed, including the water, then we add the admixture. And when we do that, we get better performance from the admixture. It improves the slump retention and the water reduction efficiency. So the best time to add an admixture in the mixing process is last. However, most people use the solution addition method, and it's added at the same time as the second part of the water. Now, we should also note that there are many different types of admixture on the market. They're defined by parameters such as compressive strength, workability time, initial slump, whatever characteristic you desire. How do you know which one to pick? Well, all these factors affect which product works for you. Is it PowerFlow 2651? Is it 2695? What's the difference? Well, we don't expect you to know, but you should talk to your local MC representative to get advice on the right product for your particular requirements. How far you need the concrete to stay fresh, how fast you need it to set, what's the strength development curve. These products are tailor-made for you to have the right solution for you. So please talk to your local representative to get the right product for your project. If we just go back for a minute to the mixing and the plant itself, we should just reinforce the fact that if we want to produce good quality concrete, mixers need to be clean and maintained. We see two brand new mixers in the picture there, but they don't look like that after a few months of use, do they? The blades get concrete buildup and can affect the efficiency of the mixer. So blades should be checked. The gap between the floor, which is circled in red, and the blade itself should be monitored so that it doesn't become too much. Otherwise, we're not mixing properly. And of course, cleaned. And that also includes in the mixing truck. Now, in a mixing truck, you have a blade in the drum. When the drum rotates, the blade agitates or it mixes the drum depending on the type of truck. If these blades become hardened, become covered in concrete, then that agitation is much less and our concrete quality can be reduced over time. So how do we prevent mixers and truck mixers from getting a buildup of hardened concrete? Well, there are mixer protection oils now that are becoming more and more popular, and they work by coating the steel and preventing the concrete sticking too much without having a negative impact on the concrete itself. So if you're a producer of concrete, then we'd recommend that you have a look at this type of system to help you with reducing buildup. Another trick that many people use around the world for monitoring the quality of concrete is to use an ammeter. Now, I don't know if you have in your plants, maybe you have seen this trick used, and it's basically that as the mixer is turning, it draws power, and therefore it registers on an amp meter. A wetter concrete draws less power than dry concrete. So the amp meter can be used as a tool. It can give an indication of the workability. And when the needle stabilizes and not moving around, that can indicate that proper mixing is achieved. Now, this is only an indication. It is not a law. It is not a true guide. So we should check the slump properly after batching, but it can be quite useful in assessing the workability. As we noted earlier, sometimes rash decisions are made during the process to speed up production. Maybe I need more concrete per hour, so I speed up. The concrete may look the same when it comes down the chute. It may feel the same, but the strength, the setting, slump retention, all can be affected by rushing. So please make the mixing cycle properly and follow that rather than cutting corners and rushing. Now, let's think about quality control. Trial mixes. Trial mixes, you probably have admixture suppliers knocking at your door all the time saying, I want to do trials. Why? Well, trial mixes are very important to do before the start of a project, residential or otherwise, to make sure that all the targets defined in the specification are met. But not only that, they're met effectively. In other words, they're optimized to do good concrete that meets the spec at the right price. So trials help us to select materials such as cement replacements, admixtures that we just talked about, but they can also be used to confirm accelerated solutions. Maybe we want to strip the columns faster so that we can build the next floor. Well, trials will help us to identify and confirm the performance of accelerators in that case, which can speed up the process and progress on the project and help us to bring the project in on time. Taking time to do proper trials definitely saves you money and definitely saves you stress as well, because you don't have to worry about meeting your targets. Let's briefly have a look what a trial process should look like. And I want you to, while you're watching this video, look out for two things towards the end that can have an impact on your quality. Okay, so did you notice anything in the video that would impact the quality? Well, two minor things, but the things we should be aware of. Even letting go of the slump cone for a second before we do the proper pull-up can affect the result if the cone moves. So we should hold the cone down until the test is finished or until we are ready to lift it properly. That's the first thing. Second thing is, what was the slump like? Was it a true slump? In this case, no, it was a shear slump. Now that helps us to identify that maybe the mix is lacking fines or has a lack of cohesion. So the mix may look okay, but we might want to look at it again to give some attention to it before we go into production. So during production, there are a number of tests that we should carry out in terms of quality control. We mentioned already the slump test. Slump test is there. You can see the true slump at the bottom left. Is used to assess the workability. It's a very simple test, but very important. And it looks for variations in the initial slump. If we're getting variations, if the slump is going up or down or not consistently, then we have a problem with our material somewhere. So we can use that as a tool to identify problems on the plant. The second one, which concrete is mainly defined by, would be the compressive strength. We make samples for maybe 24-hour, 7-day, 28-day, and we make sure it meets the project specification. It's important to keep good records. Regular testing can help us to identify any deviations that we may have that can mean that there's an issue on the plant. Tools like QSUM can help us to analyze the results and look for trends that can help us to improve the quality of our plant also. And variably, we need to also understand our standard deviation. Now, what is a standard deviation? Standard deviation is a statistical tool that measures the performance of the plant. A low standard deviation means everything's good. You have good control of your materials, your plant, your batching, everything. And you can potentially save cement as well. If you have a high SD, maybe above 5 or something like that, that means your control is not that great. And probably you're going to have cement failures or cube failures. So you need to address some issues on the plant and identify what they are and fix them. Think that we use SD in the mixed design calculation when we're calculating our characteristic strength. So running a good plant at a low SD really does save you money. It really can help you to run your plant very efficiently. Now, the next topic we're just going to touch on is the most important one, in my opinion, and that is ensuring that our staff are well trained. Let me tell you a short experience that happened to me in Ghana. I visited a plant where the batcher was having problems. He wasn't getting good quality concrete. On investigation, it turned out that the batcher had not been fully trained on the batching system. The software that he was using was in a completely different language to his normal language. And unfortunately, the installation team had just set it up and left without sufficient training. So this poor batcher didn't really know how to operate his plant. And that gives us an important lesson. The best equipment in the world is only as good as the people who are using it. So we need to ensure that our batchers, our technicians, our supervisors, our drivers, and of course the manager are properly trained and receive ongoing training to ensure that they know what to look for when there's problems. That will help us drive better quality in our concrete if everybody's working towards that goal of producing good quality concrete. It's always good to foster an atmosphere of continuous improvement. Be better than you were the month before. Improve the quality, save cement. These are the things that drive quality. See, quality is a key factor in the construction industry. And by focusing on it and ensuring all the staff understand that quality is the most important, that can really help us to be successful and differentiate ourselves in the market. Finally, let's just consider a few issues that happen on site that impact the performance and quality of our concrete. So, as we just said, if best equipment may not work, if the people don't know how to use it. It's the same with the best produced concrete, could fail if it's not treated properly on site. So let's consider a few topics: water addition, free fall, vibration, and curing. Those four things all have an effect on concrete on site. So generally speaking, it's not a good idea to add water to the ready-mix concrete once it's arrived on site. The mix design should be done and trialed, as we said, so that the on-site performance doesn't need any adjusting. It shouldn't need any water adding. If it's not meeting site requirements, then we should adjust it at the batching plant, not at the site. So adding water can lead to a loss of strength, cracking, shrinkage, segregation, and of course reduced durability. Those are things that we don't want. We definitely don't want to see those things. So just consider for a minute the effect of adding just 10 litres a metre, just to give you an idea. You increase the slump by about 20 millimetre. That may be good in the case when the workers want it a bit easier to use. But you reduce the compressive strength by 3 Newton. You waste basically the effect of 15 kgs of cement. You're throwing money away. And you increase the potential for shrinkage, increase the porosity, and decrease the freeze-thaw resistance. So certainly we need to be careful with site addition of water. There are certain circumstances where it is allowed. We have to say that. For example, if the maximum water-cement ratio hasn't been reached, then it's possible to add it on site, but it's far, far, far better to produce the concrete properly in the first place so that no water is needed to be added. Second one, dropping concrete from a height. How many times do we go on site and we see a column or a wall that has honeycombing and segregation, and then we find that the concrete was dropped right from the top? The concrete should be generally dropped from no more than 1.5 metre height. And that is clearly just to prevent us from having segregation. Aggregates will fall faster than the cement paste. Laws of gravity. So if the drop is higher, then it's much better to use tremie pipes, concrete pumps, or chutes that can control the placement and minimize the segregation. Here's why this is important, as you see on the screen. First of all, segregation. The aggregates will separate from the paste if it's dropped from a big height. So we need to make sure that we're not dropping it too high. That leads to reduced strength. The segregation, it means that in the bottom of the form, we may have a lot of aggregate and then paste at the top, and our durability is affected. And of course, we have weak areas where cracking can occur and the structural integrity of the concrete is compromised. Now, if that happens, we should use not sand and cement to repair it. We should use a proper repair mortar, which has polymers inside that are designed purely to improve the performance and structural integrity of the concrete. As we said, to reduce the risks, the following things can be used. Tremie pipe, that allows us to place water underwater, concrete underwater, or in narrow forms to make sure that we can get to the bottom of the form. This we've seen in Ghana as well. Chutes help us to incline and down to the surface of the concrete. But the most common, of course, is concrete pumps. They're used regularly now to have a continuous flow of concrete that really can be close to the surface. And we see that now in the quick video here. You'll see the concrete being poured from way up in the top right corner and being poured close to the concrete surface to eliminate any segregation and dropping. So by using these methods, concrete can be placed safely and effectively, even from a big height, ensuring that we don't get any issues with the segregation and we get a strong, durable element. Now, over vibration is something we see quite commonly. It's normal to compact concrete, right? You see vibrators being used all the time. But what isn't a problem is if people use a vibrator to move the concrete around. That can cause over vibration and segregate the concrete. So in this case, the grout comes to the surface, the aggregate goes to the bottom, and this can lead to cracking issues in a very weak top surface. So following the overlapping pattern that you see on the diagram there will help us, and waiting until there's no more air coming out and stop then, will help us to ensure that we have a well-compacted concrete. Another solution, if you like technology and advancement, is to use self-compacting concrete. Self-compacting concrete doesn't need any vibration at all. It self-consolidates. So this is an interesting future development, and it's growing in popularity now to get around one of these issues. The last one that we talk about is curing. We talk about curing very, very, very often as concrete people, and yet still we see many sites where curing doesn't happen. Curing properly is very important. It's not only a strength concern. Improper or no curing affects the concrete finish and leads to shrinkage cracking, especially in higher temperatures. There are various options, as you see in the pictures there. They include curing membranes, water ponding, and covering with plastic. Now, if you're using a curing membrane, for example, you have to carefully choose the type of curing membrane. Why? Some of them are wax-based. So if you're going to tile the bathroom, let's say, the floor in the bathroom of your residential apartment, and you've used a wax-based curing agent, then bonding to it can be quite difficult. So you have to either remove the wax-based curing agent after the concrete is set, or you need to use a curing agent that is not wax-based. And those are readily available. Again, talk to your MC representative. All of those methods that we talked about, water ponding, curing in plastic, and membranes, are designed to prevent moisture loss. They're designed to make sure the concrete has the best chance to hydrate fully and gives the concrete the best opportunity to gain its strength and be good quality. Now, of course, these factors are not in our control. But if you're called to site when there's a problem, you should know what to look for. We can help contractors eliminate the problems to help us achieve good quality concrete on site. Now, there are many, many, many other things that we could talk about tonight that go towards producing high quality concrete. But we've touched on the main ones today. The next time we will consider the topic do's and don'ts in concreting, specifically practices that we see. And at the moment, MC teams around the world in Ghana and other places are ready to help you to select the right products, the right systems, the right methods, the right solutions to solve your problems and to give you good quality concrete in a site batch situation. So that concludes really the discussion today. We have 10 minutes or so now where if anybody has any questions, you're more than welcome to ask. So does anybody have any questions you would like to ask? Or have we covered? I believe we'll make the presentation and the details available to anybody who wants them through MC Ghana.
Hello, Alan. Hello. Good evening.
Good evening. Yes, please.
I think you did a perfect presentation, so nobody wants to ask any question.
Thank you, Richard.
You want to ask a question? I have a question.
Yes, please.
Sorry, my name is Abdul Karim. I'm with the CI technical team for MC Basham Ghana.
Okay.
Regarding hello, Alan. Nice to see you again. Regarding proper. I have a concern regarding proper dispersion of admixtures whilst using drum mixers on site.
Yeah.
Now, while you mentioned that delayed addition is perhaps the best and provides the best performance regarding water reduction and retention, how would you recommend achieving this vis-a-vis the problems that you might